Hey everyone, John here. I'm the lead maintainer of the open source latterly.io. You can sign up for free, and when you sign up and log in, you'll see the career journal. This is the logged out view. Latterly is a platform that'll help you learn to code and land your first or next programming role. I am in a fantasy football league this year. We just got done with the draft, and I'm proud to announce, as a native Texan, I was able to draft Dak Prescott. I'm stoked about this. It actually makes the games worth watching to me. Go Cowboys. So, to celebrate, let's do some LeetCode. Let's do some linked lists. I will go over to the LeetCode tool. Oh no, you need to be logged in. Okay, I'll log in. And we'll find some linked list problems. I only have 73 problems done. We got to get those numbers up. We know your performance in the technical interview significantly improves up into the point of diminishing returns of around 300 to 500 LeetCode problems. So we got to get those numbers up. 73, that's a rookie number. That's a rookie number. All right. We're going to filter by pattern. We're going to pick linked lists. You could use this random thing up here. Let's do that. Let's get a random until we get a linked list. Oh, it doesn't mention the patterns. I guess I should update that, eh? All right, so we'll go this way. There's only 3 linked list problems on here. That's kind of wild. Well, let's do it. Linked list cycle. Okay. Whatever, I've done it before. We'll do it anyway. Oh, what did I do? Control Shift. Okay. Given the head of a linked list, determine if the linked list has a cycle in it. How will we know? There's a cycle in the linked list if some node in the list can be reached again by continuously following the next pointer. So we're just going in a cycle. We can never terminate. We can never get to the end of the list. That's a cycle. Here's an example in 1. 3204 has a cycle on 2 because you'll just keep looping at that 2, won't you? Interestingly, in example 3, there's no cycle. I guess the next node would be pointed to none. So you could have a situation where the next node is itself, like a self loop. I think that would be a true. But here in this case, because there's no arrow, if it was a self loop, I would expect to see an arrow pointing to itself. So in this case, there just is no next node. It's just one node all by itself. Okie doke. I'm noticing in the type signature the head is optional, so I might get a null head. In that case, there's not a loop because there's just not even a node. So here I can, man, why do I keep doing that? I'm sorry. So I'll say if not head, return false. It won't have a cycle. So that's like a little bit of an edge case. Now let's think about the time complexity. So like the naive thing to do with linked lists is you cast them to an array and then you can do some analysis there. That is a bad idea. How would we even serialize this array? You wouldn't be able to serialize it. You would just, as you convert node from linked list to list literal, naively, you would never terminate the serialization process if you were going node by node. You could do some other things. You could check the length. So you would need to get like the node ID or the reference instead of comparing by value. And so you would say, I've already visited this node, and you could terminate there. That's basically something like what we want to do anyway, but the conversion to array is extraneous. So by the time I hit the node I've already seen, I'm already ready to return false immediately. Okay, so I could maintain a list of seen nodes. That seems like a second order solution. This costs O of n memory, because in the worst case I'll need to collect every node in memory, so that's bad. Is there a way that I can do this without O of n memory? And the answer is yes. I can use fast and slow pointers. So if I have a fast pointer and a slow pointer, if they run into each other, I have a cycle. So let's do that. Fast and slow pointers. This is constant extra memory. And what about performance? In the worst case, we need to touch every node. Will we need to touch every node a multiple of times? No. The fast and slow pointer will be speed differentiated by a factor of 2. So in the worst case, you would need to do O2n, which is asymptotically ON. Worst case time complexity is O2n, because the fast one will be twice as fast as the slow one. No, the slow one is still iterating one at a time. So the fast one is at half n, but the slow one is going to be ON. So here I'll do fast and slow. And I'll say while what? While I have a fast pointer. Because the fast, if there is a termination to the list, the fast one is going to hit it first. So we'll continue our iteration as long as that fast one has not yet hit a terminal point. If the fast one hits a terminal point, we can return early. Because there's not a cycle if it's terminating, if it's a terminating list. Okay, so we will return false if we break the while loop. Here we might get a true case, but if we ever exit the while loop, we've terminated the loop, so there's not a cycle. Okay, so fast will be, and we can do this, if not head and head dot next, then we'll return false. We need both of them, so we'll initialize them this way. So the fast one is going to start at head dot next. The slow one is going to start at head. So the fast one will move 2 steps each time. If fast is slow, if they have the same reference, then we're going to return true. I think that's it. Otherwise, slow is going to equal slow.next, and fast is going to equal fast.next. That could be wrong. Question in the chat: did you ever consider quantitative development with your background in econ and software? Absolutely. Absolutely. Failed my HRT interview. That was great. I don't want to move to New York City though. A lot of the quants are up there. And I don't really want to move to Chicago either. I actually got some offers from some other quant shops scattered around the country. I won't drop names, but they're kind of like tier 2 and tier 3 quant shops. They're really like premium, high frequency trading firms like 2 Sigma, HRT, what's the one that starts with a C? Sind. Let's double check on that. I've forgotten the name. CE. Citadel. That's what I was trying to think of. I think they're like all located in New York. Yeah, Citadel. I think they're located in New York City and they don't really allow remote. So HRT is the only one that I know of that really allows remote. Which is why I interviewed there, but then I failed. Thanks for being here. Thanks for the question. Over 1,000 likes on TikTok. Y'all rock. Thank you so much. Kick. Welcome in on Kick. Okay, so before I try to run this code, what was the potential issue? I'm worried about fast double skipping. That's what I'm worried about. Slow is moving properly. Oh, fast.next could be null. Fast.next could be null. Anything else I need to worry about? No, I think that's it, unless I'm missing something. Let's see. Cool, all right, that was it. TK, hello, I'm trying to learn C++ right now. Any tips? I have no tips for you. I don't know if you're learning it as part of a university or part of a job or what. If you're doing it for a hobby, my main tip would be start with something else. Do you already know another programming language? So I do not consider C++ beginner friendly at all. I would start you with JavaScript or Python. If it's part of like a university curriculum, hang in there. I'm not telling you to drop out. But I think once you have a programming language in hand, then C++ becomes much easier. TK says, yes, I'm familiar with Python. Okay, great. That's particularly convenient because Python has something called MyPyC, which will allow you to compile types into, is it C or C++? I think you can actually choose. I think you can go to C or C++, but I forget which is the default. Anyway, if you create a program in MyPy that's compilable through, if you create a program in Python that's compilable through MyPy, then you should be able to reproduce that program in C++. So that could be a good learning path if you want to reproduce a project that you already know how it works, so that you can focus on learning the syntax of the new programming language instead of having to do two things at once, the syntax and a new project business domain. You can hold that business domain constant by building something you're already familiar with. That would be the main tip that I have. I think that's probably the only tip that I have. So what sorts of things might you know from Python that you could do in C? One, here's what I would do. I would do a basic command line tool, because I think you can do just like a pretty easy hello world one. So I'd start with that. And then other things that you do in Python, you could do like, I don't know, some data analysis or something. Yeah, some lightweight data analysis I think would be a second step. The third step would be graphical. So you want to like reproduce a MATLAB plot or a Seaborn chart. But I think that'll be much harder. So I would not do that for your initial project in C. Those are the tips that come to mind. But I'm not like a C expert, so maybe you could check YouTube channels for someone who's like really good at C. Okay, LRU cache. I've done this, but I've totally forgotten what it even means. Okay, let's design a data structure that follows the constraints of a least recently used cache. All right. Go team, go Cowboys. So we want to implement the initializer, great, with a capacity, okay. Then we want a get, which will return the value of the key if the key exists, otherwise return -1. And we want a put. So init, get, and put. Key value pairs, that's what we're doing here. Okay. Cool. Seems easy on the surface. Let's think about potential edge cases that we could run into. So by the type signature in int, I'm not worried about having to get or pull strings or nulls or anything weird. If those were handleable, that could introduce a lot of complexity. So it's nice that we get to skip on that. So I'm thinking about using a dictionary. Is there anything wrong with using a dictionary for the key value pairs? In other words, a hash map. It just seems like the most naive, kind of best fit primitive data structure whenever we have key value pairs. In theory, I guess since it's guaranteed to be an integer, you could use an array, and specifically a dynamic array, and then you could just, it's going to be equivalent to a hash map. You can look up the index by int. So maybe we could use an array if we want to do that for some reason. If we can use an array, maybe we could consider a tuple, and we could index on int as well, but the trade-off on a tuple is it would be frozen, it would be immutable. So does that help us or hurt us in this case? I think it hurts us, because we'd have to regenerate the entire tuple every time we want to put. That seems inefficient. I want put to be O of 1, I want get to be O of 1. So I think a dictionary, a hash map, or an array, any of those would be fine in Python. I think any of those would be fine. And I would prefer the dictionary just for syntactic reasons. I'll bail out to an array if I need to. Okay, and so what is my plan there? I'll be able to get runtime O of 1 and get and put. And of course, we're going to need O of n on the space because we're just growing that cache. I don't know how we would do any better than that. Now the trick is that I'm imagining an unordered dictionary. But least recently used, I think I need to maintain order. So let me read through this again and think about how that ordering is going to work. Least recently used cache. Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Yeah, so we need to maintain order. Okay, so now I do want an array strongly over the hash map. Okay. So I can keep appending my array, and then the least recently used would be the pop 0. It would be the 0 index as I'm appending right on the array. That would take care of the ordering in the eviction. But how do I look in there efficiently? Update the value of the key if the key exists. Okay, so kind of like the naive thing to do is you have to scan every time that you you have to scan the whole thing, which seems like not good. You could maintain search or like maintain sort, so that'd be n log n. That's not good either. There's some trick here that I'm missing. Is there a way that I can constrain to a finite number of sorts? Maybe I could do like a binary insert. Oh, bummer. Is that going to be the efficient solution? That's going to be a pain to implement. If I'm supposed to do a binary insertion sort to maintain the order on the put, and that would that be a log-in insert? I think that would be a log-in insert. And then when we return the value of the key, if the key exists, so you can still do that in O of 1. So all the trick here is about in the put. Moonless, welcome in. How is this a medium? It should be an easy. What is the answer? Nah, it's much more simpler because you're adding, the min and max values. As you're adding, the min and max values. Okay, how does that help us? Yes, you're right. I do know the min and max values. It's two linked lists. Interesting. Why would I want two linked lists? Update the value of the key if the key exists. You can pop in to keep track of least used. Okay, so is that two leaked? So I'm maintaining a pointer to the least used, and then I can pop it in O1. That's cool. But there are two lists, or it's two pointers on one list? Oh, this function's get and put must each run an O of 1 average time complexity. Get and put. That's a really good hint, but also I'm not seeing how to do it. You don't need a pointer since you keep track of head and tail. Okay, well, head and tail is two pointers. Is it head and tail on one list, or is it head and tail on two lists? Yeah, head and tail on one list, I can see we can pop the least recently used. But the insertion is the part, I'm not seeing how I can insert an O of 1. It's inserting into a linked list which can be argued as O1. You just add to tail. So adding to tail can be done to O1, but I need to find if the key already exists in the list. So how can I find that out in O of 1? I can only do that with an array. I can't do that with a linked list, right? Update the value of the key if the key exists. All right, I think I'm going to look up the solution on this one. I'm not seeing how to do it. I understand the popping part, but I don't understand how I can put an O of 1 under the constraint, update the value of the key if the key exists. That's the one that's throwing me. On an array, I can do that. Use a dictionary. Yeah, so earlier in the stream, I already talked about why we don't want to use a dictionary. We would want to use an array, and that's because we need to maintain order on eviction. So are you saying to use a linked list and a dictionary? Okay, so what would that do? So every node of the linked list contains a dictionary reference, and then I just update the value in the dictionary. Yeah, that could work. That's an interesting solution. I'm not sure that I like it, but it's interesting. All right, let's look at the solution. It's an interesting thought. All right, so states that we should be storing key value pairs. This means the data structure is similar to a hash map, right? It's easy enough to add these to an existing hash map. The problem is the limited capacity. When the hash map exceeds, we cannot arbitrarily remove. We need to remove the least recently used one. To keep the order, we can implement a queue. At the front of the queue is the least recently used key. Yeah, so when I've been talking about an array, this is the exact idea that I had in mind. So we would pop 0, but I see you can also use a linked list for that. Okay, the key at the front of the queue is least recently used. Key at the back of the queue is more recently used. When we insert a key for the first time, we put it in the back of the queue. When we use an existing key, we locate it in the queue and move it to the back. This is the bit that I don't see how we can do this in O of 1. Okay, if we use an array list to implement the queue, operations will cost O of n. This is because we'll be frequently removing elements from arbitrary positions in the list, which costs O of n. Got it. Sorry, why are we removing them? Oh, it's because if you update it, that counts as making it fresh. That's the reason it's getting moved. When we use an existing key, we locate it in the queue and move it to the back. Yeah, okay. So refreshing, you also need to reposition on refresh. Yeah, I didn't think about even the get would move it. I didn't think about that. Okay, so a doubly linked list. Okay, maybe that's the whole reason that I was confused, is I was assuming a single linked list. This is way more, this seems way more intuitive if it's doubly linked. And then it wants to talk about built-in. That feels kind of like cheating. I mean, I'm not opposed. Okay, it's going to use an ordered dict. I'm not opposed, but I feel like if you did that in an interview, they'd be like, nope. Okay, all right. Thanks, chat. So the whole reason that I was not comprehending is because I was assuming a singly linked list. And this is actually a doubly linked list approach. Okay, all right, let's do it. Let's code it out. So we'll make a list node. And we need self key val. We could have priv and next on there, but I guess I'll leave them off because they left them off. So self.key is key. Self.val is val. I'm going to go for next node because next is a reserved keyword in Python. But we don't need to assign that right now. So I'll just go none. And then self.prev is none. All right, cool. So we have this list node. What do we do with it? I could look at the solution, but I'm going to try to kind of do this on my own for a minute here. So whenever I initially create the cache, it's just going to be a single node. Is that right? Self.cache equals list node with oh no, we don't have any default head node. So should I add a conditional on my gets and stuff? Can I have a list node with a value of none? I guess I can have a list node with a value of none. Let's see how that works. What would the key be? There's no key. All right, so this is nothing at all. We'll just say self.cache is none. So when I put something here, let's say I'm going to put 1, 1. That's from the example 1. So I put 1, 1. Now what do? I say if self.cache. This seems inefficient. I don't think I should need to do that, but we'll go with this for now. So if self.cache, if it's there, or I can just guard it like this. If not self. It doesn't matter. It doesn't matter if I guard it or not. If self.cache, then I need to go find it. I need to I need to get it first of all. Self.get key. So this is the cur node. But that's returning an integer. Oh, I do not believe the type signature here. What do you do when you get and it's not there? Do you just return 0? I guess you could throw an error to keep the type pure. There's no way I'm supposed to do a try catch here, is there? There's no way, bro. Oh, otherwise return -1. Okay, so that's how they're handling the case. So none of them will actually equal negative. Okay. So it's non-negative. Okay. Cur value is this, and then if cur value is -1, append q. We want to append to it. And here we can get the tail. Yeah. So what would be the value here? The key in the value would be key value. And self.tail is self.head, I think. Because here you're just, it's like the new, it's the only node. So we're going to set the origin node. Thanks for all the likes. We're over 1,200 likes on TikTok. Thank you so much. Let me double check anybody on YouTube or Twitch. Not that I see, at least they're not posting in the chat. If you're lurking, lurkers are welcome too. Thanks for being here. Okay, so I'm going to try to get this value. If not, self.cache, return -1. And then in this case, I'll have a cur head equals self.head. I don't think I need anything called cache. I really just need head and tail, yeah? So here I'll say if if not self.head. This is a simpler way to do it. Why use 3 pointers when you only need 2? So I don't think I actually need that stuff down there. Okay, so if we don't have a head, let's make one, and it's the current node. Otherwise, we want, if we do have a head, we want to get the value here. And if we pull a -1, then we can append at the end. Well, that doesn't seem... It's only linearly worse, but it still seems worse. Like, I can just do the loop here. Okay, so let me have a cur pointer and a prev pointer. And we'll go down the list. So the current pointer is going to be self.head. The pre-pointer is initially none. And I'll say while cur pointer. So this is just like a standard navigation routine. This is going to take, this is not 01 average complexity. I feel like I'm doing this wrong. Okay, because I'm thinking in terms of single linked list again. Bruh, the mental model on double linked list is actually pretty difficult for me. I'm too embedded on singly linked lists. So how do I just look up? Like if I have a 10 length doubly linked list, how do I just get to 4 in one operation? Because they're not numbered, right? They're not indexed. How can you skip lookup table or dictionary for arbitrary lookup? No way. Yeah, I'm not seeing it. Well, so in Tropical, you're really stuck on the dictionary. Again, at the top, like a long time ago, I was talking about using an array. You can treat an array as a lookup table. So like a hash map where the key is guaranteed to be an integer is an implementation of an array. So yeah, I think you're arguing with the other guy in the chat, not for me. Jorge, do you think it's better for developers to move to another role like AI roles. You should be using AI. You should be using it. Do you need to change your job title? No, but you should be using it. Do it in Java, no thanks. Okay, I'm going to go back and look at the solution again because I'm not understanding how to point into O of 1. I'm not understanding that. Only if the key is ordered like characters, you can use array. Yes, that's correct. For arbitrary key, you need a dictionary. No. No, you got that exactly backwards. For an array, the keys are indexes. They have to be integers. For an arbitrary non-integer key, like a string key, that's when you need a dictionary. Or a non-primitive key. In Python, you can actually use an object as your key, which is pretty goofy to me. So here's add. What is it talking about remove? That wasn't even in the requirements. What's going on here? What's going on here, chat? Now that we have helper methods for adding and removing from our linked list, we can implement get and put. Okay, this is also using a dictionary. What does it mean doubly linked list? It's using a dictionary. Yo, is it just me or is this thing kind of broken here? This like code preview thing is kind of broken. If key is in self.dictionary, yeah, you could do this all with an array, right? So I'm happy with this algorithm, but you could, in Python, again, you could do this all with an array. This is a little simpler because I don't need to worry about out of bounds on the array. I don't need to pad the array. So the dictionary is more sparse, so that's nice. The size is capped at 3000 and it's the integer, so you can have sparse array. It wastes space. Yeah, I agree. Yeah, I agree with that. It's a little wasteful. I agree with that. Good call. I can't scroll sideways on this thing. That's a bummer. Okay, so here is what I need to memorize, basically. So what did we learn? We learned, I think, 3 things. Number 1, we like a dictionary in the LRU cache because it is more memory efficient. It's sparser. That's number 1. Even though the worst case is not any better, but like the standard case will be better. And it makes the code simpler because I don't have to pad or handle out of bounds issues. So it makes the code simpler. That's really nice too. 3, what else did we learn? We learned that the combination of a dictionary and a doubly linked list, that is efficient. I think those are the 3 things that we learned. Oh, here's number 4 maybe. This would be a good note. Whenever we put node to delete, remove. So the get and add is still confusing me a little bit. Why do I want to add and remove a node instead of just changing the value? Because add will put it to refresh. That's the deal, right? Yeah. Okay, that's the fourth thing we learned. So the fourth thing we learned is for LRU cache, to maintain freshness, behind the scenes, we want to have add and remove methods. Behind the scenes, we want to have add and remove methods. Dang, you know what? I like this question. I hate that I like this question. I hate that I like this question because what they give you is so bare bones. Like, this is the code starter. This is the code skeleton on the problem. And it looks like, oh, okay, I'll implement get input. But no, you actually need to implement two more methods that are not even predefined here. So that's one of those like brute memorization things, I guess. So least recently used, it is pretty intuitive to associate least recent usage with two things, ordering and refresh. And with refresh, remove and add is a simple refresh algorithm as opposed to updating in place. Yeah. So that's a pretty intuitive move. We want to remove and add. We refresh by removing and adding. It's like a hard refresh. How do I get the intuition around the doubly linked dictionary, the doubly linked list in the dictionary? That's the hardest one for me. And it's the hint right here. This is the hint that it's O of 1. So I need O of 1 lookup, so it's either going to be the array or the dictionary, and then I can prefer dictionary because of sparsity. Yeah, all the tools are on the table. So it is intuitive. It's properly a medium. I think someone in the chat earlier said it should be an easy. I agree it's properly a medium because all the intuition is there, but there are a number of layers, including hidden layers. So I like this as a medium. Okay, so we prefer the dictionary because of sparsity, and then we want the doubly linked list component so that we can append, pop, and delete in O of 1, and refresh in O of 1. We can do all of this in O of 1. Otherwise, with the dictionary, you're losing order, and with the array, your refresh goes to O of n. So this one right here is really where the intuition is that, hey, we shouldn't be using an array. We should be using this compound algorithm, this compound structure of a doubly linked list and a dictionary. And why does it need to be doubly linked list? Why can't it be singly linked list? Because in a singly linked list, I would be back to the O of 1 resort problem. In the singly linked list, I would be back to the O of 1 because if I pop a node out of the middle and I want to add it to the end, no, I would have a tail reference. I would have a tail reference. Can I do it with singly linked list? Okay, let me ask chat. Single linked list can only traverse forward. Yes, that's correct. Yeah, because you have both neighbors. Because you need the bidirectional restitch. That's the issue. Yep. So it's not the repositioning, it's not the append tail, it's the deletion and the restitching that has to happen there. Cool. All right, chat. I think Entropical, read the size versus key space again. Yeah, I'm reading it. I don't see why it's important. With the key space being 10K, it calls for 10K array. Is that to do... Okay, you're just talking about these constraints here. That's fine. I think this is a boring detail, personally. So, like, I'm more interested in the algorithm. Why is this so important? Not boring in the interview. Why is this so important? I'm not understanding. 10K key cannot fit to 3K size. Can you me general idea of this problem? Yeah, sure. Least recently used cache. Let's go to Excalibur. Let me see if I can ask chat to draw it. This will be fun. Draw an image. Make a high-level explanation of what LRU cache means. And that was a typo, but whatever. When the cache is full, a new item needs to be added. The least recently used item is removed to make room. So I would think of a refrigerator. Think about a refrigerator. You're putting in eggs. You're putting eggs into the refrigerator. And you want to be putting more and more eggs, but at some point the refrigerator becomes full. Which egg do you take out? Well, we want to take out the oldest, least fresh egg, the yuckiest egg. We want to take that one out so that we can make room for the new, delicious, fresh egg. Does that make sense? Let's see if we can get it to draw a diagram. Someone probably already has a diagram. I guess, I think this is not very helpful. I would rather have a process diagram that talks about the add and remove. Oh, how cool is this? ChatGPT charts. This is cool, dude. So we check it if it exists in a dictionary. If it's found, we look up the node using the dictionary, and we move that node to the front of the linked list. Cool. And then what if it's put? Check, is it in the dictionary? If yes, we update it and refresh. Move the node to the front of the linked list. This is the refresh bit. If it does not exist, we create it and insert it to the front. Because it's very fresh. So we want it to be pushed off late. We want it to last a long time before it's pushed off the capacity clip. Then we check capacity and we remove tails until we are at capacity. All right, LRU cache, I will be back to solve you another day. I've done my thinking today. I want to stew on it and then come back and write out the code on another day. Thanks for being with me, chat. Go Cowboys.